We scroll through platforms where having 1,000 connections feels normal. But if you try to replicate that scale offline, our capacity to maintain actual, stable relationships is surprisingly restricted. Curious, take the manufacturing company W.L. Gore and Associates, the makers of Gore-Tex. By trial and error, their leadership realized that whenever a building held too many employees, social cohesion broke down. Their solution was to physically restrict their corporate footprint. They capped every factory and every parking lot at exactly 150 employees. You see this specific number repeating throughout history. In ancient Rome, 150 was the basic organizational unit of their professional armies, a standard that held through the 16th century. Anthropologists studying the existing approximations of Pleistocene hunter-gatherer societies noticed a similar pattern. When a single band reached around 150 members, it almost always splintered into two separate groups. We even find it in the archaeological record. The estimated population of an early Neolithic farming village caps out at that exact same mark. This recurring cap of 150 across completely isolated eras, industries, and cultures points to something specific. It is a strict anatomical boundary. To understand why, we have to look at our primate relatives. Primates survive by forming tight protective cliques, and they maintain these bonds by physically grooming each other. Keeping a group cohesive requires immense processing power to track how everyone relates. This exponential explosion of social data is handled by the neocortex. Anthropologist Robin Dunbar found that as neocortex volume expands across primate species, their maximum group size scales proportionately. Think of the brain like a computer processor. Once the amount of social data exceeds the physical volume of the hardware, the system crashes and the group splinters. Dunbar took this exact mathematical correlation from primates and ran the numbers using the average volume of a human brain. This chart visualizes that extrapolation. By mapping our neocortex volume against the primate data, the equation predicts a human cognitive ceiling of about 148 people, casually rounded to 150. This created a biological math problem. If early humans tried to maintain a group of 150 through physical grooming, they would have to spend nearly half of their waking hours picking bugs out of each other's hair. They would never get anything done. Dunbar theorized that human language evolved specifically to solve this bottleneck. Talking acts as a highly efficient form of vocal grooming. You can talk to several people at once while foraging or working. Language acts as an evolutionary software patch, allowing us to hit our hardware's maximum capacity without spending our entire day on physical intimacy. So, what happens when a community grows to 200, 500, or 1,000 people? The biological hardware fails. The brain physically loses its ability to track the intricate web of who knows who, and mutual affection is no longer enough to keep the group cohesive. To prevent the group from collapsing, larger societies are forced to invent structural workarounds. You have to enforce restrictive rules, top-down hierarchies, and formal laws to maintain order. Now, this theory is still debated. Other anthropologists, using different network field studies, estimate our actual social limit is closer to 290, and biologists point out that insects like paper wasps manage highly structured hierarchies despite having tiny brains. Yet that limit of 150 remains stubbornly visible in our daily lives. We build digital networks to scale human relationships indefinitely, but our most stable, meaningful communities still naturally self-organized around the physical boundaries of our Paleolithic hardware.